Welcome to today's Explainer, everyone. I'm going to be your instructor as we dive into a phenomenon that once completely terrified ancient civilizations, but is now one of the absolute most fascinating subjects in astronomy. We're talking about that mysterious event where our bright white moon transforms into a glowing, blood-red sphere. So, grab your notebooks because we are going to look at the exact science behind the mechanics of a lunar eclipse.
Here is our syllabus for today's Explainer. First, the cosmic alignment. Second, the missing monthly eclipse. Third, anatomy of Earth's shadow. Fourth, the blood moon mystery. Fifth, 3 types of eclipses. And finally, number 6, how to watch safely.
All right, Section 1, the cosmic alignment, understanding the celestial bodies.
Okay, let's get right into the physical mechanics of this. To really grasp what's going on, we just need to look at how 3 distinct celestial objects interact out there in space. Step 1 is our light source, right? The sun. Normally, this light hits the moon directly, giving us that bright glow in the night sky. But then, step 2 happens. The Earth travels directly between the sun and the moon. Think of it kind of like a giant hand blocking a flashlight. Because of that interference, step 3 kicks in. Earth's massive shadow falls right across the moon. So the moon doesn't just magically disappear. It's simply passing into our planet's shadow instead of catching direct sunlight. It's actually a super simple alignment, but the sheer scale of it is absolutely mind-blowing.
Moving on to Section 2, the missing monthly eclipse. Why isn't it a monthly show?
Now, it's time for a quick pop quiz to test our orbital mechanics. Since there is a full moon every single month, why on Earth don't we see a lunar eclipse every month? Seriously, think about it. If the moon completes its orbit and reaches that full moon phase roughly every 30 days, shouldn't it smash right into Earth's shadow every single time? It is a fantastic question, and the answer comes down to pure geometry.
The absolutely crucial variable you'll want to jot down for your notes is the number 5. You see, the moon's orbit is actually tilted by about 5 degrees compared to Earth's orbit around the sun. And that means most months, the moon passes slightly above or slightly below Earth's shadow. It misses the whole thing completely. It's only a few times a year that the sun, Earth, and moon line up perfectly on the exact same plane to create an eclipse.
Which brings us to Section 3, anatomy of Earth's shadow, more than just one dark circle.
Let's define some key vocabulary here, starting with the penumbra. This is the lighter outer part of Earth's shadow. When the moon passes through this specific zone, the change is incredibly slight. In fact, it only becomes slightly darker. Most people looking up at the sky wouldn't even realize anything was happening at all.
Second up is the umbra. This is the darkest, central part of Earth's shadow. In class, this is where the real magic happens. Once the moon enters the umbra, a dramatic transformation begins. It visibly darkens as it gets covered up, and the deeper it moves into that umbra, the darker it appears to us down here.
All right, Section 4, the blood moon mystery. Why red instead of black?
So here's the big question. If the Earth is completely blocking the sun in that deep umbra shadow, why doesn't the moon just disappear entirely? Well, the answer lies right here in our very own atmosphere. When sunlight passes through Earth's atmosphere, the blue light gets scattered in every direction. By the way, that is the exact same reason our daytime sky is blue. But the atmosphere actually bends the remaining red and orange light right around the edges of the planet and directly into Earth's shadow. That filtered red light then gently illuminates the moon.
I absolutely love this quote from our source material. It's almost as if every sunrise and sunset happening around Earth at that moment is being projected onto the moon. How cool is that? And this brilliantly illustrates why we so often call it a blood moon. The moon isn't suddenly generating red light itself. It's just acting like a giant cosmic projection screen suspended in space, reflecting all of Earth's filtered sunrises and sunsets all at once.
Next up, Section 5, 3 types of eclipses, categorizing the phenomenon.
Depending on how everything lines up, we categorize these into 3 distinct types for your notes. First, a penumbral eclipse happens when the moon is just in the penumbra, giving us that very slight darkening that's barely noticeable. Second, a partial eclipse means the moon partially enters the umbra, so a dark shadow appears to slowly cover just one side of it. And finally, the big one, a total eclipse. This happens when the entire moon is fully inside the umbra, treating us to that spectacular, glowing, deep red color.
And finally, Section 6, how to watch safely, your field assignment.
Okay, so how do you actually go out and complete your field assignment to observe this? Let's quickly compare it to a solar eclipse. Unlike a solar eclipse, which absolutely requires special protective glasses so you don't fry your retinas, a lunar eclipse is completely safe for your bare eyes. You don't need any special gear whatsoever. Plus, it's visible to millions of people simultaneously. Literally everyone on the night side of Earth can just step outside and watch it at the exact same time.
Now for some extra credit, you can grab binoculars or a telescope to really enhance the view. And honestly, the best part? Because the moon moves so slowly through the shadow, the event can last for several hours, so there's absolutely no rush. You have hours to step outside, relax, and enjoy nature's absolute greatest sky show.
So, to summarize our lesson today, when you're out there watching a lunar eclipse, I want you to remember this one really profound fact. You are literally watching the shadow of an entire planet slowly cross the face of the moon. This breathtaking alignment lets us witness our very own planet's shadow suspended right there in the darkness of space. It's this incredible, real-time reminder of our place in the solar system.
Which leaves us with this final thought. What other amazing universe discoveries will you make when you step outside, look up, and simply let your curiosity guide you? The next time an eclipse is coming, I want you to remember this explainer. Step outside, look up, and never stop asking questions. Because as every good science student knows, every great discovery begins with curiosity.